Hello everyone and welcome back to Diksha Karnataka YouTube channel. Today is Sunday and in the morning you have received the question paper for KPL number 8 and I am here back with the solution for the same question paper that you have received. And if you are new to the channel, if you are wondering from where I will get the question paper, what the sir is talking about, for that you have to join our WhatsApp group. The link is given in the description. You have to click on that link and then join our WhatsApp group, and then you can download the question paper for KPL. And we have already completed 7 question papers. Today is the 8th week. So 8th week we are going to discuss about 8th question paper, and this entire thing is absolutely free. It is available on our WhatsApp channel. You can download the question paper and then you can see the solution that we are going to do. And from my standard, I think this week's question paper was pretty easy, and let's see what we can do about that. So we will start solving all the question paper one by one. A single diode can produce only half wave rectification, only full wave rectification, both half wave and full wave rectification, neither half wave nor full wave rectification. Okay, a single diode can only do only half wave. So correct answer is option A. If you have marked option A, then you are correct. If you have marked anything else, then you are not correct. Okay, now let's move on to question number 2. It is also very easy question. The N-type semiconductor is silicon doped with indium, germanium doped with aluminium, germanium doped with indium, germanium doped with arsenic. So we know that N-type, to form an N-type semiconductor, we have to dope with a pentavalent material, right? Pentavalent dopant. So out of indium, aluminium and arsenic, only arsenic is pentavalent. So correct answer will be option D. Germanium or silicon is immaterial. Both are semiconductors, both are intrinsic semiconductors. So it depends only on the impurity, and only impurity which is a pentavalent is arsenic. Okay, it does not matter on the semiconductor itself. Now, in a good conductor, the energy gap between the conduction band and the valence band. In a good conductor means it is a conductor, so the gap between valence band and conduction band, they will overlap, so the energy gap will be 0. So energy gap will be 0. Region without free electrons and holes in a PN junction is, so the region where there is no charge, no holes, no electrons, that region is called depletion region. Okay, simple enough. Now let's move on to the next question. Acceptor level in the case of P-type semiconductor is. Now what is acceptor level? There are 2 levels. One is acceptor level and for P-type, and there is a donor level for N-type. Okay, now we have to remember that acceptor level for P-type is very close to valence band, just above the valence band. Okay, so it is just above the valence band. Correct answer is this. And one more thing, that the donor level for N-type semiconductor is just below the conduction band. Okay, these 2 things you have to remember. Now let's move on to the next question. Identify the diode or diodes, basically diode /S, which is forward biased in the following set, which all are forward biased. So what is the condition of forward biasing? If you remember, forward biasing is when I said this is the P type, this is P side, this is N side, right? If you remember that current can flow from in this direction, so that is when the current is flowing in the direction of the arrow, we say this is forward biased. Now to identify if a diode is forward biased, what we have to do, we have to check what is the voltage at this point. Okay, what is the voltage, say VA, what is the voltage at this point, VB. If VA is greater than VB including sign, if VA is greater than VB including sign, then we say the diode is forward biased, right? Now if you see the first case, what is VA? VA is 0. Okay, and VB is -5. Now which one is greater? 0 is greater or -5 is greater? -5 is less than 0. Right, numerically -5 is less than 0, so diode is forward biased, so current will be gone. So this is a forward biased. forward biased. Okay, now let's see the option 2. It has 5 volt, it has 0 volt. Because it is grounded, grounded means 0 volts. Now as we say that this voltage should be greater than this voltage. Now in this case obviously VA is greater than VB, so diode will conduct. So this is a forward bias. This is also forward biased. Okay, so 1, 2 both are forward biased. Let's see about 3. In this case they have just reversed the diagram, so you have to be careful. So VA is -2 and VB is -7. So in this case also -2 is greater than that of -7 because it is less negative, it is more negative. So more negative is less, less negative is more. So in that case this is also forward bias. Be careful. This question, one of this such question will be coming in your KCET 2025. There is a high probability that one such question based on forward bias, reverse bias question will be coming to your KCET 2025 exam, because most of the other parts like the logic gate part and the truth table part, Zener diode part, they are not no longer part of the syllabus, so they are deleted. So definitely one such question is highly likely to be coming to your KCET 2025 exam. Now in this case this is 2 volt, this is 3 volt, so VA is 2 volt, VB is 3 volt. Obviously VB is more compared to VA, so this is not forward biased, this is reverse biased. Okay, so which of them are forward biased? So forward biased is 1, 2 and 3. So 1, 2 and 3 are forward biased and 4 is reverse biased. So correct answer is option C. Okay, so be careful while answering such questions. They don't fall for the trap. Okay, only 2 is appearing to be forward biased, rest of them have negative. So I am not sure if they are forward biased or not. As long as the potential of P side is greater than the potential of the N side, this is called forward biased. You have to be remember that. Now next question number 7. A piece of copper and another germanium are cooled from room temperature to 77 Kelvin. 77 Kelvin means approximately 200 minus 200 degrees Celsius, approximately, slightly less than that. So minus 200 degrees Kelvin, the resistance of, what will happen to the resistance? Each of them increases, each of them decreases. Copper decreases, germanium increases, copper increases and germanium decreases. Now we know that for normal conductor, which is a copper is a normal conductor, copper will be having a less resistance because its resistivity decreases with temperature, right? As you are decreasing the temperature, resistivity decreases, that's why its resistance will decrease. Whereas for a semiconductor, as you are cooling it down, its resistance increases. As you are heating it up, its resistance decreases and it becomes a conductor, right? That's what we learned. So the resistance of a semiconductor decreases with increase in temperature and increases with decrease in temperature. Basically it is just opposite to that of normal conductor. So correct answer is option C. Copper's resistance, copper being a normal conductor, its resistance decreases, and germanium being a semiconductor, its resistance increases. Okay, clear? Now a semiconductor has an electron concentration of 9 times 10 to the power of 3 per meter cube and hole concentration of 4 times 10 to the power of 13 per meter cube. Its intrinsic carrier concentration is, now we know that electron concentration times hole concentration is equals to intrinsic concentration whole square, right? This is the formula that we have learned. So only one formula is there from this chapter, only based on this. So what is NE? NE is given 9 times 10 to the power of 3 and NH is given 4 times 10 to the power of 13. That is equals to Ni square, or Ni square equals to 4 9 is 36 times 10 to the power of 16. So Ni should be square root of that, that is 6 times 10 to the power of 8. So intrinsic concentration should be 6 times 10 to the power of 8 per meter cube. Simple question, simple answer. Now let's move on to the next question. The impurity atom that should be added to the germanium to make it N-type. So impurity atom which should be added to a germanium to make it N-type, it is a pentavalent material. To make n-type semiconductor, we need a pentavalent material, that is arsenic. Okay, similar question that we have seen, but the language of the question is different, so that you may be confused. Okay, what do we answer? Last time there was too much indium and iodine was there, so I will answer indium right now. No, arsenic is the answer. When the conductivity of a semiconductor is only due to the breaking of covalent bond, the semiconductor is called intrinsic semiconductor. Okay, if you add external agent that is called dopant, then it is called extrinsic. Otherwise, it is always intrinsic. Okay, extrinsic semiconductors can be classified into p-type and n-type based on the dopants. Okay, but when it is only due to the breaking of covalent bond, this is called intrinsic semiconductor. Now, current in the circuit shown in the figure considering the ideal diode. Okay, so this is the ideal diode, so voltage drop across this ideal diode should be 0. That is the ideal diode. Okay, now is it forward bias or reversed bias? That is the question. If the diode is reversed bias, then there will be no current, then answer will be 0. Okay, but if the diode is forward bias, then you have to use Ohm's law, find the potential difference, and then current V is equal to IR. Right now, so on our left hand side, that is I said VA, and this side I said VB. What is the potential? This side is 1.3 volt and on our right hand side it is 1 volt. So that means that this P side has higher potential than N side. So P side having higher potential than N side, current should be flowing from P to N. So diode is forward biased. So what you can do, you can read out this circuit to be just this. You can remove the diode purpose is fulfilled, 1 volt. Now you should be remembering that if they change these values, okay, 1 volt on this side, 1.3 volt on this side, then you will not be able to draw like this. You have to answer there will be no current because the diode is reverse bias. If diode is reverse bias, no current will flow. Right, now what is the Ohm's law? Ohm's law says that V is equal to IR. Now what is the V? V is basically the difference in potential. 1.3 minus 1, that is 0.3 volt. 0.3 volt is the potential difference. Now apply Ohm's law. V is equal to IR. 0.3 equals to I times 100, or I is equal to 0.3 divided by 100, or 3 times 10 to the power of minus 3, okay, amperes, or 3 milliamperes. Okay, so 3 times 10 to the power of minus 3 ampere or 3 milliampere, whatever option is given, based on that you have to answer. Now, the electrical conductivity of a semiconductor increases when electromagnetic radiation of wavelength shorter than 248 nanometer is incident on it. The band gap for the semiconductor is. Now this is also a mixed concept question based on somewhat the concept of dual nature of radiation and matter. So what we have to do, we know that energy equals to band gap, energy equals to h nu, or this is equals to hc by lambda. Okay, so this is hc by lambda, and what is the energy given? Energy we have to calculate, right? The band gap energy, this is the minimum energy required to excite the electron. For minimum energy, the lambda will be maximum. Anything less than that lambda, it will definitely giving you that much energy, right? So hc, I told you 1240 when you are writing in terms of nanometer electron volt, right? So energy, and this is given 2480 electron volt. Okay, nanometer cancels, nanometer in the numerator, nanometer in the denominator, they will cancel. So we can write this as 1 2. Okay, 2480 is exactly double of that of 1240. So half EV means 0.5 EV. So these are the things that you have to remember. Okay, 0.5 EV is the answer. Simple question. Okay, not so difficult. The diffusion current in PN junction is. Okay, so diffusion current, very careful, they have mentioned diffusion current. So diffusion current, what is the direction of current? Current direction we generally take from direction or opposite to the flow of electron. Okay, in case of semiconductor, we can find the direction by finding the direction of motion of holes. Okay, diffusion current is when you are forming the p-n junction, immediately after hole starts move from p side to n side. Okay, so the diffusion current flows from p side to n side. Electrons flows from n side to p side. Diffusion current direction should be opposite to that of the flow of electron, so it should be p side to n side. Okay, or direction of holes. Either you can consider direction of holes or you can consider opposite direction of electron. Current is always opposite to that of the direction of electrons. Okay, so diffusion current flows from p side to n side. Be careful, and if you remember that drift current flows from n side to p side. Okay, there is electric field, because of that electric field there is a drift current flows from n side to p side. Okay. Reverse bias applied to a p-n junction diode lowers the potential barrier, raises the potential barrier, decreases the majority charge carriers, decreases the resistance of the junction. So it raises the potential barrier increases, so electrons are having more difficulty to cross the barrier, holes will also have more difficulty to cross the barrier. That is the meaning of reverse biasing. Majority carrier, or whatever you are saying, majority or minority for p and n side, they remain same. Only thing is, because of the increase in potential barrier, they cannot jump. Okay, now minority carriers present in a p-type semiconductor are due to. So what is a p-type semiconductor? P-type means positive type, right? So what is the majority carrier for the positive type? The majority charge carrier is holes. Okay, so what will be the minority carrier? Minority carrier will be electrons. Now why do we say see electrons in a p-type semiconductor? Because there are thermal vibration. Because of the thermal vibration, the bonds are still breaking and they are releasing some electrons. Those electrons are free. So current main reason is thermal agitation. Because of thermal agitation, because you are keeping a semiconductor above absolute zero. At absolute zero, this is not happen. There will be no minority carrier. If there is a question that at what temperature there will be no minority carrier, that is absolute zero. Okay, majority carrier will still be present, but minority carrier will be zero. Okay, now semiconductor device is connected to a series circuit with a battery and a resistance. Okay, so a semiconductor device, some device, we don't know what device is, it is connected to a battery via resistance. Okay, now a current is found to pass through the circuit. A current is flowing in the circuit. Okay, if the polarity of the battery is reversed, the current drops to almost zero. Now if you reverse the battery, okay, if you reverse the battery, the current becomes zero. So there is a current in this case current is zero. If you reverse the battery, then current becomes zero. Now when do we see this? So if you are connected to a diode circuit, okay, diode is connected, the positive is connected to the p side, negative is connected to the n side, then there will be a current, right? But if you reverse the battery, then what happens is that a negative side is connected to the p side and positive side is connected to the n side, so there will be no current flowing in the circuit. So basically it's a p-n junction diode. Okay, either they can mention it's a diode or they can mention it's a p-n junction. So it's a p-n junction diode. Okay. Now, if the forward voltage in a diode is increased, the width of the depletion region. So you are increasing the forward voltage. Okay, so forward voltage increases means the depletion region decreases. Depletion region slowly decreases and becomes zero if the applied voltage is more than that of the barrier potential, right? If the applied voltage is more than the barrier potential, the barrier will be completely gone. Okay, so barrier potential will become zero in that case. Now minority carriers in a p-type semiconductors are, so as I said, minority carriers in a p-type semiconductors are only free electrons. Okay, it is not holes. Holes are basically majority charge carriers, so holes are not minority carriers. Minority carrier in a p-type semiconductor, which is a positive type semiconductor, majority carriers, the name comes from the majority charge carrier, right? In case of n-type semiconductor, which is a negative type semiconductor, so negative means electrons, so electron should be majority carrier, so minority will be opposite to that. Okay, so minority is opposite to that of the majority carriers, right? The forbidden energy gap in a germanium is 0.72 electron volt. Given Hc equals to 12400 electron volt angstrom, the maximum wavelength of radiation that will generate an electron hole pair is. So basically same problem. So energy is given here. and we know that that is equals to hc by lambda. Value of hc is given. Okay, so they had asked you to find the value of lambda in terms of angstrom, right? So that's why now unit is given ev angstrom, right? So E is 0.72, hc is 12400. 1240 is for nanometer, 12400 is for angstrom divided by lambda. Here lambda is in angstrom, so lambda will be 12400 divided by 0.72. Okay, now you can solve this without using calculator. How can we solve it? We have to use slightly approximation. 12400 divided by, we will assume only 0.7. Okay, we will assume only 0.7, so that we will ignore the 0.02. So the difference will be minor and our answer will be slightly higher than actual answer because we have removed 0.02 from the denominator, right? So now let's solve. 12400, 0.7 was there, so I removed the point, I added 10 here. Okay, I removed the point and added one extra 0 here. Now let us cancel. 7 1s are 7. Okay, 7 1s are 7. Then 5 is there. 5 4 54. Now 7 7s are 49. So 54 out of 49 is again 5 is there. So now it is 50, right? Another 5 is there, 50. So what I will do, I will include this problem here. 50 means 7 7s are 49, so almost 50, and so 50 part is done. Then there are 2 more zeros here, so I will write 17700. Okay, now you have to count. So if you see, all the options are given same, only the value of decimal is varying. So how many digits are there? 1 2 3 4 5. So how many digits should be there? 5 digits. 1 2 3 4 5. All of them are either more or less. Okay, for example, this is 1 2 3 4 only, this is 1 2 3 4 5 6 is there, and this is only 1 2 3. So correct answer is option D, 17222. Okay, so 17222. So that is the correct option, right? So what you have to do, you have to count the number of digits. In this case, you have to count the number of digits. That's why I don't go beyond 50. You can score one more. Okay, then 10 would have been come, then 7 1s are 7, then 30 would have been come, then again 7 8s are 28. So you can do that. But that is not required in this case. Okay, 7 4s are 28, sorry. So you can do that, but actually we are approximately finding the values, right? So approximation, for approximation, you just need to count the number of zeros correctly. That is the number of digits correctly. That is the main objective, right? So correct answer is, if you do that calculation completely, you will get 172222 point something. Okay, we ignore the point. So this will be the correct answer, angstrom. This is called smart calculation. Now, if NP and Ne are the number of holes and electrons in an intrinsic semiconductor, then what will happen? In case of intrinsic semiconductor, number of electrons and number of holes are equal. So we can write that NP should be equals to Ne. Right? So this is the last question from semiconductor electronics. Now let's move on to the second chapter, that is nuclei, right? So from nuclei, let us look into the first question. In nuclear fission, large amounts of energy is released. We know that nuclear fission, which is basically the sophisticated name for atomic bomb. Atomic bomb is a process where nuclear fission occurs, uncontrolled nuclear fission occurs, and when it is controlled, we get the power that is called nuclear power plant. Okay, so nuclear power plant where controlled fission happening, and we are harvesting the energy, and if you keep it uncontrolled, then it will become an atomic bomb, right? The why it is happening? Because mass is getting destroyed, and that mass is getting converted into energy. We have discussed that, right? The total mass difference before and after fission. So mass difference before and after fission is the source of the energy, right? So this is the basically the source of the energy. Rest of the options are just distractors. The mass of helium nucleus differs from the total mass of 2 neutrons and 2 protons by 0.03 mu. This difference of mass, if converted entirely into energy, will be equivalent to, here they have given 1 AME is equal to 1.7 times 10 to the power of minus 27 kilograms. So we know that from Einstein's equation, E equals to mc square. What is m? M is 0.3 mu. Now if the answers was given in terms of electron volt, we could have multiplied by 930 and we could have found the value in terms of electron volt, but they have not given you the value in terms of electron volt. So what we have to do? We have to first convert it into kilograms. So 1.7 times 10 to the power of minus 27 kilograms. Now you have to remember that c square, instead of writing every time 3 times 10 to the power of 8 whole square, what you will do from now on, we will use this directly. C square means 9 times 10 to the power of 16. Okay, so from now on we will simply use 9 times 10 to the power of 16. So if you are confused why I am writing this, then you should know that because it is coming from c square term, and c square is basically 9 times 10 to the power of 16. Okay, clear? Now let's do the multiplication. So how can we do the multiplication? Let me write this 0.03 as 3 by 100 times 1.7 times 9 times 10 to the power of minus 27 plus 16, so minus 11, right? 27 minus 16 is 11, and because there is a negative sign, so we will use the negative sign, right? Now let's do the multiplication. Okay, let's multiply 3 times 17 first. 3 times 17 is 17 into 3, that is 51, right? 51. Okay, 17 to the 34, 17 3 is a 51. Now there was one decimal here, so one decimal we have added, times 9. Now there was a 100 in division, so 100 in division, what I will do? I will increase the negative power by 2, right? 100 division means negative power by 2, increasing negative power by 2. So now 5 times 5 times 9, 5 times 9 is 5 into 9 is 45, right? So 45.9, there is one extra 9, so 9 ones are 9, so 45.9 times 10 to the power of minus 13. Now if you check all the options, you have to be careful, only for 4.59 is given, so 4.59, if you write 4.59, that is you are absorbing one extra dot, so it will be reduced by 1, so it will be minus 12. So 4.59 times 10 to the power of minus 12 joules. Okay, be careful, this is just to check. The formula is easy, only thing that you have to be careful when you are doing the calculations. Okay, now the protons are able to exist inside the nucleus of an atom because a strong attractive nuclear force binds them, attractive electrical force between them. The repulsive forces between the positive charges on the proton is small at small distances, which is wrong. The nuclear fusion forces. Oh no, that is also not correct. The correct answer is strong attractive nuclear force between them. Strong attractive nuclear force actually binding the nucleus together. Okay, now let's move on. The ratio of nuclear radii of elements with mass number 216 and 125 is. So very interesting question. We know that radius is equals to r naught a to the power 1/3. R naught is a constant, okay, and it is basically the radius for hydrogen atom, right? So now they have given you A is 216 and 125. So for 216, say this is R1, okay, this say R1, this is say R2, okay. So what is R1? R1 is R naught 216 times 1/3. Now if you know 216 is basically 6 cube. Okay, this is you have to know. You can multiply 6 is 36. 36 times 6 is 216, right? So it will be R naught times 6, right? Cube to the power 1/3. Similarly, R2 will be R naught times 125 1/3. Now what is 125? 125 is easy. 125 is 5 to the power cube, 5 cube, right? So it will be 5 R naught. Okay, so they have asked you to find the ratio between R1 and R2. So R1 by R2 is 6 by 5. So R1 is to R2 should be equals to 6 is to 5. So 6 is to 5 is the answer. Correct answer is option B. Two nucleons are at a separation of 1 times 10 to the power of minus 15 meter. Okay, so 1 Fermi. The net force between them is F1 if both are neutrons, F2 if both are protons, and F3 if one is a proton and another is a neutron. Then which of the following relation is correct? Now you should remember that when the distance is very small, that is of the order of 1 Fermi, 2 Fermi, up to 3 Fermi, okay, nuclear forces are very active. Okay, if you are going more than this distance, they say 3 Fermi, if you are going more than 3 Fermi or 4 Fermi, then nuclear forces slowly dissipate, slowly decrease. But at this distance, 1.10 to the power minus 15 distance, nuclear force will be very active, and it will overpower all other forces. Okay, it will overpower all other forces. Electromagnetic forces will be almost in comparison, you can ignore that, and you can say that at this distance nuclear force is so strong that it will overcome the electromagnetic forces, and the nuclear force between two protons, a proton and a neutron, and between two neutron is constant. So correct answer is option A. This is only for the distance when the distance is very small. If the distance is large, then this is not correct. Okay, so this is only correct when the distance is very small, otherwise nuclear force will be 0. We'll see in another problem. Okay, if M, Mn and Mp are the masses of AZX nucleus, neutron and proton respectively, then now we know that A is mass number, Z is the atomic number. Atomic number means number of protons. So mass Z times Mp is the mass of proton, total mass of proton, and A minus Z times Mn is the mass of neutron. This is the total mass of the nucleons. Now total mass of the nucleons is always more than that of actual mass of the atom, right? Actual mass of the nucleus. Why? Because of this mass defect. Because there is a mass defect, we call this term as mass defect. That mass defect is the source of the energy that is binding the nucleus together. That is called the mass defect, right? Mass defect per nucleon. That is the source of the energy required for a stable nucleus, right? So basically we can say that M must be less than that of A minus Z Mn and Z times Mp. So correct answer is option B. M should be less than, not greater. Okay, M cannot be greater and it cannot be equal. If it is equal, then mass, the atom will no longer be stable. Okay, the nucleus will no longer be stable. Now mass defect in a fusion reaction is 0.36%. Energy liberated when 1 gram of material undergoes fusion in kilowatt hour. This is very interesting unit. Okay, so it is not in terms of joules, it's not in terms of watt, it is kilowatt hour. So what is happening is that 1 gram of material undergoes fusion. So 1 gram of material undergoes fusion, and the efficiency of the fusion is 0.36%. 0.36% means 0.36 divided by 100. Okay, so x percent means x by 100, that is the fraction. So 0.36% means not 0.36, it is 0.36 by 100. Now this is given in terms of grams. Okay, so grams to kilogram you have to convert. This is the mass defect, this is the mass that you are destroying, right? Now energy is basically this is equals to this times c square. So 0.36 times 10 to the power of minus 5 times 9 times 10 to the power of 16. Now don't ask me why I have written 9 times 10 to the power of 16 here. I explained that in a while, just a few moments back. Now this is in terms of joules. Okay, so this is in terms of joules. Now if you want to convert it into kilowatt hour, then you need to remember one conversion, that 1 kilowatt hour is basically 3 3.6 times 10 to the power of 6. Okay, so you have to apply the values of 1 kilowatt, then hour is 60 into 60 to convert it into seconds, then you can find this value. So energy is basically 0.36 times 9 times 10 to the power of 11 minus 5, 16. So I have done it 11, 3.6 times 10 to the power of 6. Okay, so now we have to cancel these two. So how can we cancel? To cancel this, we have to make it 3.6. If we make it 3.6, then we have to reduce one power from here, right? Because it was 0.36. So if you take if you borrow 110 from here, then it will be 3.6. So 3.6 cancels. So we can write this as 9 times 10 to the power of 10 minus 6, that is 10 to the power of 4. So it will be 9, 1, 2, 3, 4 zeros. Okay, so 90,000. So 90,000 is the answer. Okay, so correct answer is 91234, right? Not very difficult problem, but it's an interesting problem because I hope that most of you aware of this conversion factor, the unit 1 kilowatt hour, and if you are not aware, then you must see this problem to find the correct answer. Now, two protons are kept at a separation of 40 angstrom. Fn is the nuclear force and Fe is the electrostatic force between them. Then, so now we know that nuclear force is active at a small distance of few fermions, okay, 1, 2, 3 fermions or 4 fermions. But here the distance is given 40 angstrom. So angstrom is of the order of 10 to the power minus 10, okay, and that is also 40 fermion, whereas maximum range of nuclear force is 10 to the power of minus 15. Okay, after that the value of nuclear force drastically decreases. Okay, it is very strong within this range, and after that the value decreases very rapidly. So we can say that the electrostatic force is stronger compared to nuclear force, very stronger compared to nuclear force. So correct answer is Fn is less than electric force Fe. Okay, but electric force is inverse square law. For this distance, if you inversely square it and then you multiply it, it will be very high value, right? So electrostatic force will be very high, but nuclear force will be very small because it is outside the zone, right? Outside the range of the nuclear force. So this is a very interesting question. Okay, most students will write this answer without thinking that okay, nuclear force is bigger than electrostatic force, so we will answer this. But you have to remember that the range of nuclear force is very small. So outside that range, when the distance is more, nuclear force is almost zero. Okay, now let's move on to the question number 29. A nucleus disintegrates into two nuclear parts which have their velocity of the ratio 2:1. The ratio of their nuclear sizes will be. So basically this is not directly related to nuclear physics, but very interesting. We know that in any collision or any breakdown, when something breaks apart, the thing that is constant is the momentum, right? So momentum will remain constant. Initial momentum was 0, final momentum is mv1 minus mv2. One is suppose going in this direction. If they break apart, what is happened? One will go in this direction, another one will go in this direction. So suppose this is v1, suppose this is v2. If you take one positive, another one will be negative. Automatically, initially it was at rest. Initially velocity was 0. Right, so it was at rest, so initial momentum was 0. So suppose this is m1, this is m2. So what we can write, m1 v1 equals to m2 v2. Okay, this is from the conservation of momentum principle, right? So m1 by m2 equals to v2 by v1. Okay, now v1 by v2 is given, v1 is to v2 is given 2:1, right? So we can write this 1 by 2, right? Because v1 is 2, v2 is 1. So we have put these values. Now After that, what you have to do, you have to remember one more formula, that mass is basically density times volume. Now, since it is breaking apart from one single nucleus, we can say that density is almost constant for both of the sister daughter nucleuses, right? So, what only thing that will change is the volume. Okay, this is volume, right? What is the formula for volume? Volume is 4/3 r cube, right? Pi r cube, sorry, 4/3 pi r cube. So, mass is basically proportional to r cube. Now here r is the size of the radius of the nucleus, size of the nucleus, right? So basically r denotes the size, r mass r denotes the size, right? So what we can write here is r1 cube by r2 cube, rest of them are constant, so they will cancel, equals to half, right? So r1 by r2 equals to 1 by 2 to the power 1/3. 1 does not matter, no matter what is the power of 1, it will always be 1. Okay, so r1 is to r2 equals to 1 is to 2 to the power 1/3. So this is the answer. 1 is to 2 to the power 1/3. Very interesting question. This is one of the very interesting question, slightly different from whatever we have solved so far. So that's why I included this question in the question paper. Now let's move on to the last question. Binding energy of nitrogen nucleus given n mass of the nucleus is this. Okay, so binding energy, they have asked you binding energy, total binding energy, not binding energy per nucleon. If they ask you binding energy per nucleon, the value will be slightly different. Okay. So what is the mass of a proton? Mass of a proton is approximately 1.007. There are one more value, two more decimals, I am ignoring that, and mass AMU, in terms of AMU, obviously. Okay, because it is given in AMU unit. So I will write this. Mass of neutron is 1.008 U. Approximate values, right? I am decreased the values, so when we get the actual answer, our answer should be more than what we are calculating. Okay, because we have reduced both MP and Mn by small fraction, right? Now what is the total mass of the nucleons? Total mass of the nucleons, say capital M, total mass of the nucleons is Z times MP plus A minus Z times Mn, right? That is the formula. This is total mass, and mass defect is minus the mass. So what is Z? Z is 7 times MP, 1.007, plus what is A is 14 minus 7 is another 7, and Mn is 1.008. So I am explaining it, that's why I am doing it in detail. Okay, I know most of you will start multiplying 7 times 1.007 plus 7 times 1.008 and you will solve it. But those who are a little bit weaker in the class, for them I am explaining this as much as possible. So this will be 7.077 is 49. So 1 we will shift in this side, right? 7 1s are 7.0, 7 8 is 56. So 56. Okay, now add them. 14.155 in hand 1, 490 in hand 1, 000, so it will be 14.105, right? So this is the total mass. So delta M, that is mass defect, will be M minus N, right? So it will be M minus M. Okay, so that for that what we have to do, we have to minus that given value, 14.003, right? I am ignoring the rest of the values, they are very small, right? So it will be 0.102. So this is the delta M. So delta M we have calculated, delta M is 0.102, and only thing that you have to calculate is the energy. Okay, so binding energy is nothing but delta MC square or in terms of EV, I told you to remember the value 930. 930, 931. Okay, I am using 930 in this case. So you will get around 94, about 94 point something. Okay, but as I said, I have reduced these values, so correct answer will be more than 94. Okay, you can multiply it, you will get 94. Okay, so actual answer will be slightly more than 94, so that correct answer should be 102, because all the other options are less than or 2 are higher than that of 94. Because we reduce the values, our actual answer will not be 85 but 101. Be careful. Okay, when two answers are almost closely matched, okay, difference is closely matched, then which one should we take? Okay, should we take 85 or should we take 101? Okay, if you have used a calculator, if you have used all the correct values of MP and MN, then you would have got the value 101. But because you are approximated the values, you have reduced the values. Okay, more important thing is you have reduced the values. Okay, and 1 point reduction is huge because this factor 930. Okay, if you remember more decimals point, say 1.0028 and 1.00834. So if you remember all the decimals, you can use that, but that will be waste of time. If you do smart calculations, you can answer questions without using calculator, without having any difficult concepts. Only thing that you have to remember, whether you are reducing the actual value or if you are actually increasing the value. If you are reducing the value, then your answer should be more than what you have got. Okay, and if you are increasing the actual value, then your answer should be less than what you have got. That is the point, right? You have to remember this point. Now I have reached the end of this discussion, and I will be back with your PU1 chapters from tomorrow. I will be solving PU1 chapters as quickly as possible. Also, I will be doing one chapter revision each week, so that chapter will be included in your KPL syllabus. So I will be informed you after we complete few chapters from PU1. Before next Sunday, there will be one second PU chapter revision, very important. Also, we will be doing important questions once our entire syllabus is over. So after entire syllabus is over, I will be doing 60 to 30 to 60 questions every day, so that you are prepared for your KCET 2025 exam. So don't worry, I'll be back with PU1 chapters from tomorrow. Till then, bye.